Okay, this is a 5-pointer from 1992 under the category Arithmetic with Star Operations, and it reads, how many positive integers less than 50 have an odd number of positive integer divisors? So what they mean by integer divisors is just, let's say you take the number 8. You can write 8 as 1, 2, 4, and 8. So this is 4 divisors. And 4 is an odd, so 8 doesn't satisfy that condition. So one theorem that we're going to need to satisfy this problem is the divisor theorem. So you take a natural number such that, and this is its prime factorization, so if you can write it in this prime factorization, then it has that many prime positive divisors. So like an example of this is if you take 48 and write it as 2 to the 4th times 3. Using this theorem, it should have 4 plus 1 times 3 to the 1, so 1 plus 1 factors, which is equal to 10. So if you write out 48's factors, you'd get so it has 10 factors, which does match up with what the theorem predicted. So for a number to have an odd number of factors, this expansion every term would have to be odd. So these are all odd. So any ai plus 1 is odd, which means that ai is even. By definition, if ai is even, that implies that it can be written as 2 times ki, where ki is just half of ai, but we can use this notation to rewrite its prime factorization. So you just substitute for every ai. So n would be equal to this quantity, which is p1 to k1 times p2 to k2 all the way to pr to the kr squared. This is just using laws of exponents. So since this part in here is an integer, n is a perfect square. So basically what we got from this is that odd number of factors means that n is a perfect square. So since we know that we're looking for perfect squares and n is less than 50, we just count up all the perfect squares less than 50. So that's 1, 4, 9, 16, 25, 36, and 49. And that's 7. So our answer is 7.